Hi all, and welcome back. I hope you're finding this series of videos from me useful. If there's a particular topic you want me to cover, please let me know in the comments below. In this video, which follows on from my last, I am going to cover a method of determining your approximate longitude at the time of meridian passage. I say approximate as it is unfortunately not possible to determine an exact longitude using this method. The Earth rotates on its axis at a fairly constant rate, with one full rotation taking 24 hours. As it's turning at a constant rate, it's possible to determine our position on the sphere based on a fixed point or event, which is the principle that we are using here. As we know the time of meridian passage at Greenwich, and assuming we have an accurate time that we observed meridian passage at our present location, we can use the difference between the two times to calculate our approximate longitude. Now the reason we can only obtain an approximation is due to two things. The first is that the almanac gives the time of meridian passage as hours and minutes. Therefore that introduces a best case accuracy of 15 nautical miles. The second issue is that as a body approaches its highest point, its change in altitude occurs very slowly, and it's simply not possible for us to accurately determine the exact time with a sextant. As such, you'll usually only have an accuracy of at least 1 minute with your own timings. Despite this, I am sure you'll agree that in a practical situation where you find yourself using the sextant and you have no alternative means, you're most likely going to be in open ocean, and an accuracy of around 15 nautical miles doesn't make a huge difference. Okay, that's enough waffling, so how do we do this? First, we need to know the time that we obtained our meridian passage reading from the sextant. Purely so that this video follows on from my previous one, we'll use the time that was used in the previous video example, which was 13:49:50 UTC on the 10th of April 2016. It's important to note that your observed time must be in UTC, not local time. Now, armed with this information, we take our nautical almanac and turn to the daily page for the 10th of April 2016. If we look at the bottom of the right hand page, we see the time of meridian passage of the Sun on the 10th of April at Greenwich is given as 12:01 UTC. As I used the meridian passage pro forma in my previous video, I'm going to continue on with it. If you haven't already done so, you might want to watch that video first. Now we take the time given in the almanac and subtract the time we observed from it, which gives us a time difference of 1 hour, 48 minutes and 50 seconds. The last stage is to simply multiply this by 10. If you're using a calculator that accepts degrees, minutes and seconds, it's as easy as entering the time difference, making sure you enter the hours as degrees, the minutes as minutes and seconds as seconds, and multiplying it all by 15. Depending on your calculator, you may have to convert seconds to decimal minutes. The answer given on your calculator should come out already formatted in degrees, minutes and seconds, which is your approximate longitude at the time of meridian passage. If your observed time of meridian passage is less than the time at Greenwich, then your longitude is east. If it's later, your longitude is west. As such, in our example, our longitude was approximately 027 degrees, 12.5 minutes west. I hope what I have explained here makes sense to you. If not, please let me know in the comments below. If you found it useful, please click the like button, and if you want to be notified when I next post a video in my Merchant Navy series, remember and subscribe, as my posting schedule is a bit random due to me being away at sea. Until next time, safe sailing.